Now let's consider an example that has some similarities with this one and also some similarities with previous examples. Let's say we have a solution x of t equal 4e to the negative 2t times the cosine of, let's make this 40 pi t plus pi over 6. Now the 4e to the negative 3t, or negative 2t, is going to have a graph that looks like this. We start at 4 and we decrease on some time scale, approaching an asymptote with the positive t-axis. Now cosine of 40 pi t, that corresponds to motion around a reference circle. Starting at pi over 6. So let's see, pi over 6 would be right here, and moving in this direction with radial velocity 40 pi radians per second. Now that's a lot faster than in the previous example, but we see that the functions have similar representations. The x-coordinate at this point is going to be about here. The graph of just this function, let's see, I think I can slip it in here. Is going to look something like this. We're starting at a positive value of x, and x is going to be decreasing as we move around this way. So we're going to have some maximum amplitude. We're going to start a little closer to the equilibrium because we're starting at the pi over 6 position, and we're going to then move down to 0 and then to negative maximum amplitude and so forth. So our graph will look something like this. And move on, etc. Now our function x of t is going to be the product of this function for e to the negative 2t and this function cosine of 40 pi t plus pi over 6. The function that we get when we combine these two, well, we're multiplying this by this. The cosine function has an amplitude of 1, so it's going to go down to negative 1 and up to 1. When that's multiplied by this function, then when the cosine is at its minimum or maximum value, we're going to be at a value that corresponds to the distance of this function from the t-axis. Now, if all you've done in your mathematical life up to this point is plot functions on a calculator, you won't have ever considered what happens when you have the graph of two functions and need to multiply those two graphs, or you might never have considered this. The way it's going to work out, and I'm not going to go into all the detail to teach you how to do this. This is something you should have learned previously, and I can always give you references to materials that will teach you how to do this. But if we take our function 4e to the negative 2t, and then the function negative 4e to the negative 2t. So here's 4e to the negative 2t. Here's negative 4e to the negative 2t. Now, why would I plot the negative and the positive? Well, we're going to multiply this function by a cosine that alternates between negative and positive values. The result of the process is going to be a function that looks something like this. It starts at a value that's pretty close to the maximum value and decreases. Now, the function's going to decrease to a point here, and then it's going to come back and it's going to increase. And it's going to decrease, going to increase, decrease, increase, maintaining the same period, but always coming down and just touching this 4e to the negative 2t function. Now, why is that? Well, when the cosine reaches value negative 1, then this value is going to reach the value 4e to the negative 2t multiplied by negative 1. So wherever t is, we're going to hit the negative 4e to the negative 2t function. And we're going to come up and do the opposite here. I have to say I'm not explaining this really well because the explanation would need to go into a lot more detail. But again, this is something you should have learned in pre-calculus. And if you're not completely sure of this, if you don't understand what's going on here, should have been reinforced in your calculus classes. I can give you some references. For the purposes of the present course, what we see is an oscillation that, instead of maintaining a constant amplitude as it might in this case, has a progressively decreasing amplitude. And we can't really call that an amplitude, but I'm still going to use the term. So that the amplitude decreases according to the function 4e to the negative 2t. The period of the function is the period of the cosine function. So that this function can describe a function that has an equilibrium position here, is pulled out beyond the equilibrium position, maybe given a little push, and passes through the equilibrium, comes over to the other side, slows down, comes back, but not as far as before, and oscillates with decreasing amplitude. The oscillations gradually dying away. So what we have is periodic oscillation decreasing, put quotes around it, amplitude, which would be like 4e to the negative 2t.